So friends, Oza, back to you with all my mobile numbers, email, all details. We are in the laboratory environment now. These talks are most relevant to engineering institutes, that is degree engineering institutes and diploma engineering institutes. I was just writing to one of the professors of one of the engineering colleges that at BVM Engineering College we have developed 60 experiments in power system protection and power system laboratory. We had 4 subjects: power system 1, power system 2, power system protection, and advanced power system protection. So if you consider 10 experiments each, I think you will agree that more than 10 experiments, it is difficult to complete. Real experiments, if you complete, then 40. And if you do 12, then at the most 48, then 50. 60 or 62 experiments in any case cannot be completed. Therefore, I was taking extra sessions, and that also all batches I would not be taking. And I hope you will agree that all other teachers cannot teach like me. Therefore, many students were coming to extra sessions. In BVM, the strength was 60 to 70 students in a class. 40 students were coming for extra sessions. I was showing them my timetable, they were showing their timetable, and then sometimes 3 groups came, 4th group will come, and then 5th will come, and they will find that there is no time. Then they will ask that, sir, you are telling that you are ready to talk, you are ready to teach from 12 p.m. to 2 a.m. at night. So at least 6 to 8 after college hours are complete. Are you ready? And I was saying that yes, I'm ready, and I was teaching them in extra sessions. So friends, for any institutes, I can develop many experiments. We have tried. This is the 4th one. This is the 4th experiment. Radial feeder protection. Radial feeders do exist in practice. All 66 kV and 11 kV are radial feeders. From 66 to 11 kV substation, 11 kV line will go. That is first feeder, right? And then, uh, uh, sorry, 66 kV line will first. Then from 66 to 11 kV, 11 kV line will go, and then a distributor of 415 volt will go. This is a radial feeder, fed from one end only. On 415 volt side, there is no source usually. So radial feeders are very much used in practice. How to protect that radial feeder and how to find out the settings of these relays. That is what we are interested in. Right now, we would be talking about phase relays only. We would not talk about ground relays. We have talked a lot in theory, and a lot much of theory, lot many questions are available in my module 3 of power system protection in Adapt Me, the mobile app Adapt Me, to be downloaded from Google Play Store, and you can buy it, you can subscribe it. But right now, free of cost, this video, radial feeder protection. And this radial feeder protection will not go for 3-phase. Someday we will talk about 3-phase, but today, to be simple, we'll talk about single phase and neutral, and we'll find out how to do the settings. Friends, yes, next slide. What is motivation? Every experiment has a motivation. The motivation is radial feeders fed from one end are found in practice. Therefore, we must study. Usually, we use IDMT over current relays, giving normal inverse characteristic for protecting such radial feeders. And coordination of these relays, that is to find out the plug setting time and time multiplier setting TMS, so that the relays operate as fast as possible and yet as selectively as possible, is very important and very critical exercise. The other important problem is ZS by ZL ratio affects the performance of IDMT relays. ZS is the impedance from source till relaying point, and ZL is an impedance from relaying point till fault. If you talk of radial feeder, the last third or fourth feeder, ZS is very large and ZS by ZL is very large. In that case, normal inverse relays are not justifiable, and therefore we have to go in for very inverse or extremely inverse over current relays. And therefore, these different types of relays are used in practice. So this also we should try to understand. And that we will not understand theoretically. We will understand purely practically. I told you, by eyes, by hands, by ears, not by theory, not by brain. Because when I'm teaching theory, some students are sleeping, some students are thinking something else. And the teacher is also so often, myself, thinking something else, not teaching. Or while I'm teaching, I'm just mechanically teaching. That is not that. Practice, do it by your hands, hands-on exercise. Moreover, justification of very inverse and extremely inverse relays we will see, and we will see all these aspects in this experiment. So exciting, my friend. Romance, romantic. I am feeling romantic. As a newly married couple, when goes for, so to say, क्या बोलते हैं, honeymoon, the boy, 25 years boy, very romantic about the girl, very romantic about the man. I am, my friends, 72 years old, very romantic for power system protection. Are you? Are you romantic? Are you excited? If you are, then yes, carry on further. What is the theory? We will not talk much of theory. No doubt, we will have to do relay settings, because otherwise we will not be able to understand the experiment. So that part of theory we will do, but not much of theory. The whole of the power system can be subdivided into number of radial feeders. Otherwise also, 220 kV, 132 kV system can be subdivided into number of radial feeders. Generally, such radial feeders are protected by overcurrent and earth fault relays. Earth fault right now we will not be talking. Right now, and in the 11 kV and 66 kV system, surely radial feeders and overcurrent and earth fault relays alone are used. For higher voltages, 132 kV, 220 kV and above, distance protection is used, but yet overcurrent and earth fault relays are used as backup. So we would be very happy to study this. Next slide. So we are going to use this simple figure right now, a theoretical figure. First of all, the theoretical figure. Generator is there, GT is there, generator breaker is there. Then I've got a line AB. It does not mean that there is only one line. From A, there can be 10 lines emanating. From B, there can be 10 lines emanating. From C, and from D, there can be many loads, right? Now from D onwards, there is a 415 volt distributor. See, I have removed transformer for simplicity. But at A, there is I am seeing GT. At B, there is a transformer, say 220 kV to 132 kV. At C, 130 to 66. At D, 66 to 11. Something like that. Transformers are there. Right? Last, from D, 415 volt distributor is going. Distributor cannot be protected by relay. It has to be protected by fuse only. Because if you use relay, you cannot use relay alone. You cannot pass 100 ampere through relay. So you need CT. And relay does not know how to interrupt the fault current. CT does not know how to interrupt the fault current. So circuit breaker is required. So CT, relay and circuit breaker, cost of three things is not viable for distributor. You use fuse. And fuse is all three things. My friends, fuse is all three things. Fuse is relay because it senses the fault. Fuse is CT because you do not need CT. Fuse is up to 500 ampere, 450 ampere are available in the market. And fuse is interrupter also because when the fuse melts, it is interrupting. So it is doing the function of all the three. But very elaborative, very comprehensive protection is not possible with the fuse. But that is not required for 15 volt. So there is a fuse. If there is a fault in 415 volt distributor, the fuse will protect. If fuse fails, then R3 will give backup. Right? If fuse fails, then R3 will give backup. Similarly, if there is a fault in CD section 3, R3 will operate primarily, R2 will give backup. This is known as remote backup. And R1 will backup R2. So this is all what I told. I have written here. You may probably tell that if R1 fails, then who will give backup? My friends, here I am talking about transmission line protection, but in generator there are many relays, so R1 will be backed up by generator and generator transformer relays, right? So that is what I have written in this slide. I am skipping this slide. Now, where do I need normal inverse, very inverse and extremely inverse relays? You see, my fault current in the particular in the last feeder, start of the feeder and end of the feeder, I have shown two currents, multiples of PS, that is two currents I have shown. You can see I have shown two currents. Please, yes, one current is this is the higher current, this is lower current. So if I use normal inverse characteristic, this is normal inverse characteristic. Number one. Then I get T1 as a discrimination time. That means for two different fault currents, one fault current is more, another is less. But the characteristic is such that I do not get very good time discrimination. Difference between two time is very less. Therefore, normal inverse will be not justified. Therefore, I have to use very inverse. And if I use very inverse, then T2 is the time discrimination. Better. If I use extremely inverse, yet better. So I hope you can understand what is the significance of normal inverse, very inverse, and extremely inverse. I see that in power system protection and switchgear, teachers teach that disk type relay, normal inverse. Forget about extremely very inverse, long time inverse, 1.3 second relay, 3 second relay. IEEE, normal inverse, very inverse, definite time. Then other kind of this some countries are using some another standard. Some countries is using Rayleigh inverse curve. Some countries is using RXIDG curve. Nobody knows this. Nobody knows this because we are not knowing full protection. We are given 3 lectures per week. 15 weeks. Out of that, 2 weeks will go in examination. So we get 12 weeks. 12 into 3. 36 lectures. My dear friend, I need 80 lectures. I cannot teach protection in 36 lectures. So forget about that 3 lecture theory. Whosoever has made it wrong. I don't take wrong means I do agree that after learning that much other things, the student should be able to self-learn. That I agree. They have the theory. Those who have designed this 3 lecture theory, they say that for learning for 45 hours, another 45 hours, student should self-learn. But for those 45 hours also is not self-learning. How will he self-learn for next 90 hours? When I'm giving these videos, I'm hearing many good comments in videos that, sir, we have never heard such lectures. Therefore, my dear friends, good lectures, good professors, good theory, good practice is a very requirement, not only for protection, for all subjects, so that Not for engineering is not meant for teaching. Engineering is not meant in college walls. Engineering is meant for field practices where a student will be able to do a good work after learning good theory. So friends, this next. The other types of current relay is 3-second relay and 1.3-second relay. 3-second relay means at PSM is equal to 10, the time of operation is 3 seconds. Another kind of relay, lower time at PSM equal to 10, time of operation is 1.3 second, right? Long time inverse relay, which is overcurrent come overload. At 5 times the plug setting, time of operation is 30 seconds, very long time. It serves the purpose of overcurrent, that is fault versus fault come overload, right? Very inverse relays are less prone to ZS by ZL ratio. Extreme inverse relays are yet less prone. So all these things we have talked, right? So very inverse relays are faster in operation for closing fault, right? Another important thing is very inverse relays match with the characteristic of heating characteristic of transformer or induction motor. So very inverse relays are better in that respect also. Extremely inverse relays are better because they are very good coordinating with fuse. Fuse characteristic and extremely inverse characteristics are more or less parallel. Fuse characteristic is roughly I raised to 3.6 T equal to K, if I mistake not. And extremely inverse is also more or less similar. So both are parallel. And when characteristics are parallel, they are best matching. Therefore, the last feeder should be extremely inverse relay because it has to coordinate with fuse. I hope you get my point. I'll repeat. I will see the figure. Last relay R3. Last relay R3 has to coordinate with the fuse. So R3 should be better if it is extremely inverse relay. So friends, this is all the theory. And we want to reveal these facts experimentally. That is what we want to do, right? So for this, we will use the uh, figure 1.3, that is experimental simulation. So we will see the experimental simulation. In practice, you see, the CT secondary current and relay rated current are same. CT secondary current is 1 ampere, so relay also will be 1 ampere. CT secondary, so where CT secondary should be 1 ampere, where CT secondary should be 5 ampere is also an exercise where one has to learn. You cannot have anything 100 bar 1 or 100 by 5, 1000 bar 1 or 1000 by 5. It is not like that. There is some engineering. We will learn that engineering someday, not today. Not today, because everything cannot be talked today. Because if I talk everything today, then time is also a constraint. And my suspense is also there. My authority will be lost. My importance will be lost. Sorry, my friends, in lighter tone. I'm not that very important person. And relay rating should be same. City secondary relay rating. But what we are going to do? We are differing. Our city is 10 by 5 and our relay is 1 ampere. That is a practical requirement. Why? Because if I pass 10 ampere, 10 ampere is a very small current. 10 ampere if I pass in primary, I will pass 5 ampere in secondary. And if I have got a 1 ampere relay, that 5 ampere is 5 times, so relay will operate. Otherwise, if I use 5 ampere relay, then I will have to pass 50 ampere or 100 ampere through primary. Then I will need very thick wires and the contactor, etc. of 100 ampere rating. My experimental cost will increase. I want to reduce the cost of the. I am telling that I am for reduction of cost of the experiment. This radial feeder protection experiment is not going to be very cheap. It is little costly, but not as costly as what we'll think. I have not given the cost here. In certain experiments, I'm going to give the cost also. So if I see the figure is this. My experimental figure is single phase version. I will use ammeter. If I want to remove ammeter, I can remove 0 to 5 ampere ammeter. Then first section, 10 by 5 CT, R1. And then 9 ohm is my transmission line. You see, it's a small table, but 9 ohm is a transmission line. Bus A to bus B is 100 kilometer away. But I am rather simulating that line by resistance. Transmission line is resistance plus reactance. Why I am not using reactance? I am not using reactance because in overcurrent relays, I am not concerned with phase angle. I am not using two quantities, voltage and current. Therefore, inductance I don't require. And 9 ohm is a typical resistance or inductance. 9 ohms, 15 ohms, 20 ohms. They are typical impedances of line. So all the three lines are 9 ohms, right? So A to B, B to C, C to D. And then the distributor. Distributor is protected by fuse or in modern days MCCB in actual practice. But here I have got a small, I mean I have scaled down the things. So I am using an MCB. And MCB is also 0.5 ampere. So my distributor current is 0.5. You will agree that no distributor current can be 0.5 ampere. Distributor current is 100 ampere, 200 ampere, etc. But this is scaled down. 185 ohm and 385 ohm resistances are load. Another 185 ohm resistance, yes, please, I'll show. Another is a fault resistance. Really, fault resistance is existing in field. It may not be as large as 18 ohms, but here this is my practical requirement also, because if I create the fault in first feeder, then my source will be shorted fully. That is wrong. My equipment will be damaged. Therefore, 18 ohm is a practical. S1, S2, S3 are fault switches. Fault in first section, fault in second section, fault in third section. And fault I can do anywhere in the line, because I'm carrying out the fault. I'm creating the fault through variable cursor of the third terminal of a variable rheostat. So I can create a fault anywhere in the line as the fault occurs anywhere in the line in the practice. So this is exact simulation of my transmission line, and that I am showing in laboratory. I am not using breakers because breakers are costly. Therefore, in place of breakers, I am using contactors. These are contacts of contactors. Contacts of contactors C1, C2 and C3. Three contactors I am using. Right? I hope you have understood. I hope you understood this figure. Going to the next figure, the control circuit. How do I control? Controlling means I should be able to make the feeder on. C1, I should be able to make it on manually. I should be able to manually make the feeder off, discharge the feeder. And when the fault occurs, the contactor should be automatically off. These three things should happen. See, these are happening. First feeder, देखिए, first column, first line. PB1, if I press PB1, PB2 is NC button, A11 auxiliary relay contact is NC, then C1 will be energized. As C1 is energized, this C11 will close. So this line is through. First thing, C11 will close. Then this is C41, this will give, hold on, because PB1 is a spring loaded button. I will press, and when I remove my hand, it will go away. But then C1 will remain energized because it will give hold on path, right? And if I want to manually make off, I will press PB2. Similarly for second line, similarly for third line. What will happen when fault occurs? When fault occurs, say if I go to third line, when fault occurs, IVS will operate. First, what will operate? First relay will operate. This is a disk type relay. You can use a static relay also. You can use a numerical relay also. This radial feeder has nothing to do with a kind of a relay. Try to understand. I am not talking about electromagnetic relay alone. But in our practice at BVM, we had used electromagnetic relay because I had prepared the laboratory in the year 1986. First numerical relay came in Indian market in 1990. right? So obviously I had no numerical relay at that time. So I used this. So this is that, this is, kaha gaya mera cursor? Yes, this is the moving contact, right? This moving contact closes, then IVS is a shunt reinforcing unit. So it will assist this main contact. It will assist this main contact, right? It will assist this main contact. So IVS closes, T2, if T2 is closed, then IVS closed, IVS closed, then this is closed, then A3 will energize. A3 will energize. A3 energizing, A3 1 will open out. A3 1 open out, C3 will de-energize. And if C3 de-energizes, then that fault in third section is automatically disconnected, isolated. 40% is isolated. That is what is happening in the field. It is happening here too. If there is a fault in distributor, MCB will trip. How can I create a fault in distributor? I will go on reducing this rheostat so that MCB operates. But I have to see that MCB should operate and R3 should not operate. That exercise I have to do. I hope you understand, right? So similarly for second line, second feeder, R2 will operate. First feeder, R1 will operate. But now the another thing, if R3 fails, then R2 should give backup. R3 fails means there is a relay R3 in your laboratory. Take a hammer and blow a hammer. R3 ko tod do, phad do. Break R3, then R2 will give back. That should not be done, because then what will you do with the next batch? So failure of R3 you have to simulate. How am I simulating failure of R3? I am opening out this switch T2. So even if relay operates, this A3 cannot energize. And if A3 cannot energize, then C3 cannot open. If C3 cannot open, then because this T1 is closed, A2 will energize, and A2 energizing, A2 1 will open, and therefore C2 will de-energize, and second section will give backup. R2 will give backup. Similarly, if I want to give backup to R2 to backup to R1, I will open out switch T1. So switch T1 and T2 are backup switches. So I am simulating backup like this. I hope you have understood. These another contexts I am using to sound an alarm or light a lamp, so that you may come to know that relay is operated. Actually, for all the three relays, there should be three different lights, but because I am doing the practical on single table, I have done it like this. And also, when C1 is getting energized, right? When C1 is getting energized, oh, cursor is going away. When C1 is getting energized, in parallel I have got a light LED. That will light, it will come to know that C1 is energized. If C1 trips, then it will go away. Similarly, C2 and C3. So this is the whole thing. This is the whole thing. I hope you have got this whole thing. This is the control circuit. So what is the description of control circuit? Everything I discussed. So I would not be repeating. This video is with you. Video is available in the whole world. YouTube is available in the whole world. You can see the video whenever you want to read. You can pause the video and you can read. My friends, I've done quite a lot much of labor to prepare these experiments, and I'm teaching these experiments at no cost. Nobody in the world teaches at no cost. I've heard one person at Vadodara. I will not name that person. It's not good to name anybody, but one person somewhere, forget about Vadodara, somewhere. He is so intelligent, no doubt, he is very intelligent. But you have to ask him a question. You go there and tell him that I have a question, the solution of which I want. So he says that put 500 rupees. For asking a question, not for answering, try to understand. For asking a question, 500 rupees or 1000 rupees, whatever. Asking a question. I am allowing you to ask a question. If you don't pay the money, don't ask a question. Go away. Get out of my door. Then put a question. This is a question. Yes, the answer to this question will cost 1.5 lakhs of rupees. Are you ready? Put 1.5 lakhs of rupees and I will answer this question. People are charging. I am not charging. I am a teacher. All teachers, all gurus in past, they have taught. Dronacharya taught Arjuna, no doubt. Dronacharya was fed, khana pina mil raha tha. Bhishma Pitama was giving him food and everything. That is another thing. But he was not for money. Sandipani Rishi who taught Krishna was not for money. I am not for money. That does not mean that I don't want money. I need money for living. I've got a family of 9 persons. I have to feed them. I want money. But then I don't want money like that. So please, you can go through this. I'll be going to next slide. Description of control circuit. Once again, same thing I described. I'll skip this. Now what I will do? I will create folds at the start of the section and at the end of the section. So that is what I've done. Right? So I'll show you that slide. I'll show you that slide. Oh my Lord. Am I correct? Am I showing that slide? Yes. IF1 just at the start of the feeder. Just at the start, just after C1. That means if AB is 100-kilometer line, first fault IF1 is just 10 meter away and IF1 dash is 100 kilometer away. IF2 similarly, second section. IF3 dash, third section. Yeah, these readings I have taken. These readings I have taken. For 230 volt supply, 12.77 for F1, F1 dash 8.51. F2, F1 dash is same. I hope you will agree. Do you agree or shall I show? Shall I show? F1 dash, F1 dash and F2 are same because F1 dash is 100 kilometer away and F2 is just 10 meters away from bus B. So IF1 dash and IF2 are going to be same. Yes, same. So that I have done. These current readings I have taken from 230 volt supply and that 9 ohms resistance. You can also do that. Now, what is the enjoyment? What is the excitement of this? Let me see. What I'll do? My problem is this, that the current difference between F1 and F1 dash 12.77 and 8.51 is 4.26 ampere. Whereas for F2 and F2 dash is 2.13 and F3 and F3 dash is just 1.27 amperes. Therefore, in last feeder, the current difference is so low that the time difference for normal inverse characteristic is also very low. So for that, relay R3 must be extremely inverse relay. So T3, T3, I've shown to you another slide where extremely inverse relay, the time difference is maximum. So for the same difference in current, time difference is good. Therefore, where ZS by ZL ratio is large, you should use either extremely inverse or very inverse relay. So that is what I want to show. You have to do some observations and calculations. What will you do? I have got 0.5 ampere distributor. But now you see, in experiment, you have got a batch of 15 students. Usually in Gujarat, we have engineering colleges, we have a batch of 15 students in one practical, because 60 is a total strength. We will have 4 batches. So I get 15 students. So if I get exercise of one one that 0.5 ampere distributor, then one student will calculate and the others will copy. So I don't do that. What I do, I said to 3 students that you take one distributor, that is 0.5 ampere. To another three student, I say you take 2 distributors of 0.5 each, that is 1 ampere. So in distributor, the current passing is 1 ampere. Therefore, through last feeder, the current passing is 1 ampere. Similarly, 3 and 4. I give, so out of 15 students, roughly 16, 4 students will have to do calculations. Now, out of 4, at least 2 will do calculation, 2 will copy. Let them copy. They do not want to learn. They do not want to excel. They do not want to be good field engineers. Those who want to be good field engineers, they will do. And when I was teacher, those two who were copying, I used to ask them question, what is this? So they are caught. So they are frightened of me. कि भाई ओझा साहब होंगे तो मर जाएंगे, करना ही पड़ेगा. कोई दूसरे टीचर को हम दुल्लू बनाएंगे. We will make him fool. But you cannot make fool Mr. Oza. So 1, 2, 3, 4 distributors I am giving for different. So I am now taking 0.5 ampere, only one distributor, and with that I am doing the exercise of plug setting and time multiplier setting. Plug setting, there are 3 rules, very obvious. Plug setting should be more than maximum full load current, otherwise the relay will operate for normal current. Pickup varies from 1.05 to 1.3 because plug setting is a threshold. Relay may pick up anywhere from 1.05 to 1.3 times the plug setting as per standard. And for backup, R1 must reach up to F2 dash. Let me see F2 dash. Oh, sorry. R1 must reach up to R1. R1, my dear friends, figure is coming slowly. R1 should reach up to F2 dash. That means up to bus C. Then only R1 will give back up to R2. And R2 should reach up to F3 dash. So these are the three rules that you have to take. Then this figure 1.8, which we have seen many times, I skip off this figure. I skip off this figure and I start with observation. I am taking one distributor 0.5. So my current drawn from third feeder is 0.5 ampere. So relay R3 primary is 0.5 ampere. Relay R3 secondary, because 10 by 5 is my CD, so 0.25. And that means 25% of 1 ampere. But my minimum setting is 50 to 200%. My dear friends, if you have a numerical relay, it gives from 10% to 500%. So probably you could have set at 25% also. But forget about this. Right now I am taking 50 to 200% in 7 equal steps. 50, 75, 100, 125, 150, 175, 200. So 25% minimum means I have to take 50% only. So plug setting of R3 is 50%. Plug setting of R3, rule of 1.3 by 1.05, because that is the variation in pickup. So it should be higher than 1.3 divided by 1.05 of 0.5. That gives me 61.9%. And similarly, R1 is 100%. So R3 50%, R2 61.9 means next higher is 75. So 75, R1 is 100%. 50, 75, 100. Time multiplier setting. For time multiplier setting, you have to rather grade R3 with the fuse. So what I do, I have plotted a characteristic of MCB. I don't know whether I have that slide. Let me check up. I'm sorry. I'm sorry. I do not have that slide. So I'm sorry, but you can appreciate that I have plotted the characteristic of MCB, right? I plotted the characteristic of MCB by passing different currents, 0.5 ampere, then 0.55 ampere. Probably somewhere I have given the table. Let's see. We will see where we have given table. So I take the current R3 and then I have taken the current at 2.5 ampere because highest current is 2. Beyond 2.5 the MCB operates instantaneously. It is a 0.5 ampere MCB, 2.5 is 5 times. So beyond 5 times it operates instantaneously. And if it operates instantaneously, then R3 is not going to operate. So MCB will certainly operate and R3 will give backup. I have to check up to 2.5 ampere only. At 2.5 ampere, time is 1.97 second. I will show you because right now we will just go on searching and that will because I started at 7:45 and it is 8:20, so it's already 20 minutes have gone. Probably I'll take 1 full hour for this because it's a long experiment. So at 2.5 ampere, time of operation of MCB is 1.97. So R3, I will add 1 second to that. Usually between two relays discrimination margin, I use 0.25 second. So why 1 second for MCB? Discrimination margin between MCB and relay. Why 1 second? Why discrimination margin between two relays 0.25 second? Suspense. Suspense means you have to spend money, you have to subscribe module 3 of mine, you have to read my book, you have to purchase my book, you have to phone me, you have to call me, you have to make all labor, then only you will understand. But right now, take it for granted that 1 second is a discrimination margin. So R3 should operate after 2.97 second. So TMS of R3 is 2.97 into log 2.5. Why log 2.5? My current is 2.5 ampere. Right? The current passing through primary is 2.5. So in secondary 1.25. But my setting is 50%. So 1.25 divided by 0.5 once again becomes 2.5. So my PSM is 2.5. So 2.97 into log 2.5 divided by 3. So my TMS is coming out to be 0.39 and hence I select 0.4. So TMS of R3 is 0.4. Go further. See, this is what I was telling. I've taken the readings through MCB. I've passed 0.3 because 0.5. 0.5 is usually 1.3 is the MCB factor. 1.3 times 0.5, it won't generally operate. 1.3 times 0.5 is roughly 0.65. But however, it is operated at 0.59 also, but very high time, 1.113.67 second, right? So at different currents within what time MCB has operated, that experiment I have done really by my hands, right? So you have also to do by your hands. And I have used 0.5 because I want to scale down the things. And at 2.5, 1.97, just more than 2.5, I could not measure. I have written 3.8, but I could not measure. It is instantaneous because instantaneous current, when the MCB operates instantaneously, it is difficult to measure the current. So I have taken 1.97 second in earlier calculation. I hope you will agree. So this is experimentally done. This is all experimental, nothing theory. So now R3 I got 0.4. So R2 R3 coordination. Fault current is 6.38 ampere. Why fault current is 6.38 ampere? Yes. Yes. Let us see. Yes, this IF2 dash I have to take. R2, R2, R3. I have to take IF3 or IF2 dash. What is IF3 or IF2 dash? IF3 or IF2 dash. IF2 dash or IF3 6.38 ampere. So I am using 6.38 amperes, my dear friends. 6.38 amperes. R2 R3 coordination 6.38. So PSM of R3 6.38 divided by 2 CT ratio divided by 0.5 because 50% is the plug setting. So PSM is once again 6.38. What is top? My TMS I have calculated 0.4. So 1.49 second. Discrimination margin between R2 and R3 0.25. Why 0.25? Suspense. Suspense. 1.74 second. PSM of R2 6.38 divided by 2 into 0.75 because R2 plug setting is 75%. So PSM is 4.253. Therefore, what is the TMS? TMS is 0.364. So that is also 0.4. That is also 0.4 on the same lines. TMS of R1 is also 0.4. So finally, my results are like this. Really, R1, R2, R3. R1 I have set at 100%, R2 I have set at 75% for one distributor. If you take 2, your settings will be different. If you take 3, your setting, and that exercise you must do. I would request all viewers to do this exercise, my dear friends. And if you let me know, then I will be more than happy. I will be a happiest person if I get responses, because everybody likes praise. Praise everybody likes. सबको अच्छा लगता है. Everybody likes praise. The lion went to the rabbit and told that is my mouth smelling bad, smelling bad? Is eating non-veg. So obviously his mouth is. So that rabbit told, yes, your mouth is smelling. खा गया उसको. Why you are telling me that? He went to some another animal. He or she was smart. He saw that that other person was eaten away. So he said, no, it is not smelling. It is smelling very nice. सुगंध आ रही है आपके मुंह से तो उसको भी खा गया. You are telling lie. My mouth is smelling bad. So he went to शियाल को क्या कहते हैं लोमड़ी. I forgot the name. Fox. He went to the fox. Fox is very intelligent. He told fox that, is my mouth smelling? Oh, I'm sorry, sir. I'm suffering from cold. So my sense of smell has gone. So he was saved. Everybody likes praise. If you praise me, I will like. If you tell me that we have done and we have found out the result, I'll be happy. These are the results for one distributor. Yes, friends. So procedure of time setting is done for normal inverse. For very inverse, you can do same thing, but the formula is different. 13.5 into TMS divided by PSM minus 1. Similar exercise you can do for extremely inverse relay. The exercise, the formula is different. For very inverse relay, the results are like this. R1 is 100%, R2 is 75%. I'm not showing, but I've done myself. I've done in rough, and I'm just showing the results finally. Because in research papers also, they are showing the results only. Because research papers are 3 pages. Nobody will understand what they have done. They have done 150 pages and they're writing 3 pages. Right? And that paper is published in IEEE. And then people said that such and such person has 150 papers on his name. 150% means his students, his PhD students, his master students. Poor B Oza has no paper on his, or probably hardly 3-4 papers at his discretion. I am telling to my boys in PDPU and Nirma that PDPU, the best institute in Gujarat state, best institute in Nirma, they are inviting me for giving lectures. I am asking student, what is your CPI? 9.2, 8.5, 7.2, 6.9. I tell that poor fellow B Oza, Bhuvanesh Oza is 5.45, being called by big institutes. So what is the purpose of marks? So try to understand. R1 is 100%, R2 is 70, because plug setting does not differ, system is same. But try to see, TMS has changed. TMS of R2 and R3 has reduced. Just see, TMS of R2 is 0.4 normal inverse, TMS of R2 0.3 very inverse. That means very inverse relay operates faster than normal inverse, yet maintaining the selectivity. That is the advantage of very inverse relay, and we want to reveal this fact practically, and we have revealed this fact practically by hands and eyes, by hands-on, not by theory. And therefore, I always tell my professor friends that don't talk what is plug setting, what is time setting, what is relay, what is the function of the relay. Don't talk these rubbish things in practicals. Practical means practical. Practical means this, relay operates faster. And we have proved that by really doing the exercise. If you use extremely inverse relay, it would have been yet better. So the procedure, what is the procedure of the experiment? We will vary 380, 350 and 185 ohm resistance. We will reduce that and we will change the current through MCB varying from 0.5 to 4, because 0.5 is the rating and at 4 ampere it will operate instantaneously. So in this range I vary. What I have to see, that in this range MCB should operate first and R3 should operate afterwards. Otherwise, the coordination is wrong. I will tabulate this. Fault current, status of MCB operated, status of R3 not operated. If that is the case, your experiment is correct. Then what I do, that vary the 350 ohm and 185 ohm resistors such that the current radial feeder from 0.5 ampere, confirm that MCB operates. So same thing repeated, right? So remove the emitter. Now what I have to do, because I'm going to pass very large current, so I have to remove the emitter from the circuit and carry out the time measurement exercises which I have done, right? Which I have already done. That I have done theoretically, but you can measure practical time also, and derive the next table from the above table and replace the normal inverse by very inverse relay and repeat the procedure. And one should note that the experiment can be conducted using static and numerical overcurrent relays too. Nothing is specific about electromechanical relay. This is an exercise. Radial feeder exists. Radial feeder can be protected. It can be protected by electromechanical relay, it can be protected by static relay, it can be by numerical relay, it can be protected very nicely, my dear friends. And for that, I have done an exercise in one of the tutorial classes to configure the numerical relay. Exercise was little difficult, I know, but then this is. So what I am doing? F1 dash, I am creating a fault. What is PSM of R1? Calculated time of operation. I can calculate theoretically. I have got the formula. Observed time by timer. What is the error? When I go to R2, for F1 and F1 dash, R2 will not operate. See, for F1 and F1 dash, R2 will not operate. Check up for F1 and F1 dash, for F1 and F1 dash, because R2 is not concerned. Fault current is coming from generator and going to F1 and F1 dash. R2 will not operate. So there is dash. When I come to R3, for F1, F1 dash, F2, F2 dash, R3 dash does not operate. But R1 operates for everything. F1, F1 dash, F2, F2 dash, F3, F3 dash. So that is what I have done, my dear friends. That is what I have done. And that I have tabulated. I have tabulated, and this tabulation you can do, you can fill up this table, right? And using the filling up of table, you can conclude something. What you can conclude? I will see that what is the difference of time of operation of F1 and F1 dash for R1. The time difference will be very large. For R2, it will be smaller. And for R3, it will be so small that normal inverse is not justified, and therefore you have to use very inverse or extremely inverse. That is my point. For time measurement, you can use this circuit. Semaphore indicator also you can see. Semaphore indicator is just an indicator to show the status of circuit breaker, because circuit breaker is in switch yard and the relay is in control room, panel is in control room. So right sitting in the panel control room, you can see the semaphore indicator. We had purchased the semaphore indicator and we have in BVM laboratory this semaphore indicator, so that students can know that this is what they are going to see in practice. So all BVM students are very good in practice. Many BVM students have been taken up by L&T and by many consultants because BVM students were very good at power system protection. I'm sorry, I should not say. But the fact is, Mr. Bhuvnesh Oza was teaching power system protection. And I should also agree that Bhuvnesh Oza could teach such a good power system protection because 100 times better than Bhuvnesh Oza, Dr. Madhav Anant Date taught him power system protection. 100 times better than Professor Bhuvnesh Oza, Dr. Madhav Anant Date, who is no more now, who is not in this world. He taught me power system protection in such a good way. And he was my guru, not teacher. Shikshak nahi the, he was my guru. I was in his contact right from 1967 when I entered BVM, and I was in his contact right up to 2002, 5 seconds earlier to his death. So, my dear friends, because of Dr. Datte, Bhuvnesh Oza is existing, and because of Bhuvnesh Oza, you all will be existing. So, friends, please try to see all these things. So, this is timer circuit. You can measure the actual time of operation. What is the conclusion of experiment? Discrimination between MCB and last relay R3 can be perfectly achieved. We have seen selectivity between R1, R2, R2, R3, normal inverse, very inverse. Backup protection can be seen by using those switches. Effect of ZS by ZL ratio also we have seen. Difference between time of operation F1, F1 dash, F2, F2 dash, F3, F2 dash. In case of very inverse relay, selectivity is better, yet the time of operation is less. If the relay operates faster and yet maintains the selectivity, it is always a good protection. In numerical relay, it can be done even faster. You see, discrimination margin of 0.25 second is not at all required in numerical relays. Discrimination margin of 40 millisecond is enough. I have told it once when I was talking about the numerical relays. But yet we can go on telling as many times as possible. And if I cannot tell in these videos, you are most welcome to contact me. I have given my number. And my friends, I am available free of cost. I don't charge. Gurus don't charge. But yes, time will be a restraint. Time will be a restraint. You ask me a question today, I will reply after a week. That is quite possible. Because if so many people will start asking questions, right now about 10-15 people have started asking questions. Tomorrow 100 will ask. Day after tomorrow 1000 will ask. So difficult. Anyway, very inverse relays are less prone to ZS by ZL ratio. Question. You have to reply. I am only reading out. I am only reading out. I'm not going to answer. What is the function of semaphore indicator? Draw an AC circuit and DC control circuit of a feeder protection. What do you understand by overshoot of a relay? What is the significance of resetting time? Resetting time means relay is operated fully, and then the relay has circuit breaker is operated, so fault is cleared, so relay comes back. Within what time it comes back to its normal status, normal non-operative status? That is a very important consideration in power system protection. For numerical relays, that resetting time is practically zero, instantaneous. For static relay, maybe few milliseconds, 20, 30, 40 milliseconds. For electromagnetic relay, disk type normal inverse relay at TMS equal to 1, when it is fully operated, it takes 10 seconds to come back to normal. Normal inverse. Very inverse relay takes 26 seconds to come to normal, roughly. Extremely inverse relay takes 45 seconds. Just useless. They have to be thrown. Therefore, my dear friends, I repeatedly tell to all universities, those who are hearing me, all viewers, all universities, all teachers, throw away electromagnetic relay. Throw away electromagnetic relays from your syllabus. Useless. They cannot be used because the relay must reset within 0.3 second, because 0.3 second is a flashover time. If it is a transient fault, within 0.3 second it has to reset, which electromagnetic relay cannot do. It is useless in modern interconnected system, smart grid, microgrid. It cannot be used. In big institutes where people are talking about papers and researches, they talk about microgrids and this, but yet they keep that electromechanical relay, disk type relay in syllabus. I just don't understand. Why do they keep this electro? From tomorrow onwards, no university should have electromechanical relays in the syllabus. What do you understand by backup protection? What is the meaning of remote backup protection? How does the source impedance affect the choice of the relay to be used in radial feeder protection? What are the IDMT? Why IDMT relays are more important in practice? Why is the transmission line simulated by resistance only? Why have we not used inductance? What are the factors to be considered for deciding the settings of phase relays and ground relays? I have not taught, but I have asked the question. Explain the control circuit of the experiment. Why discrimination margin between MCB and R3 is 1 second, and why discrimination margin between two successive relays is 0.25 second? Suspense. And my dear friends, what I was telling, BVM, my alma mater, my mother, who taught me right from 67, I am in contact with Birla Vishwakarma Mahavidyalaya since last 50 years. बिरला विश्वकर्मा महाविद्यालय में मदर, हम भारत माता बोलते हैं. देखो, किसी देश को माता, रशिया माता नहीं बोलते हैं कोई, अमेरिका माता नहीं बोलते, भारत माता बोलते हैं. हम सब लोग माता में मानते हैं. तो बीवीएम मेरी माता है, मेरी, जिसको मैंने पढ़ाया. सो उसके वहां मैंने एक्सपेरिमेंट डिजाइन किया. उसकी फिगर तो मैं वर्ल्ड को दिखाऊंगा. आई विल शो टू द होल वर्ल्ड दैट दिस इज माय बीवीएम and this is my practical of radial feeder. No doubt, they are electromechanical relays, but you can replace by static relays. You can replace by numerical relays. 3 relays, 3 feeders. You can see the MCB, everything. Push button for making on, push button 2 for making off, push button 3 for resetting, timer contacts, everything. And power circuit and control circuit are also given. When student comes, when teacher comes, everything is ready-made. You see, nobody has to ask. Now what happens when I go to college and I ask the question that, what about this experiment? Do you know? No, we do not know, because I have joined the college since last month only. And the earlier teacher had designed the experiment and we do not know anything. What nonsense! Any teacher who designs the experiment should prepare a very good document so that it is available for 100 years. Mahabharata was prepared by this Vedvyas. Everybody knows now because he had prepared good documentation. This is BVM. My friends, remember BVM. This is a practical setup of BVM. Yes, friends, coming to an end, 1 hour. But I like a good sentence. There exists no God. A very, very controversial statement. There exists no God. भगवान कहीं है नहीं कि भाई चलो देखो यहाँ मिल गए भगवान, पीला पीताम्बर पहन के. कृष्ण भगवान, He has taken a flute in his hand and he's no, God is like that. What exists is godliness, Bhagavatta hai. What exists is godliness. And that godliness surrounds you. आपके आसपास godliness है. How are you breathing? How are you? See, I'm moving my hands. How am I moving my hands? I'm speaking. I'm speaking. So good protection. Who is speaking? I'm not speaking. God is speaking. My dear friends, God is speaking. I am not speaking. Protection is not taught by Bhuvnesh Oza. Protection is not taught by Madhavanand Date. Protection is taught by God, the Almighty. Godliness exists. There exists no God. What exists is godliness, and that godliness surrounds you. आपके आसपास है. We are all in the same ocean. We are in same river, same ocean. Friends. Therefore, remember adapt me. Remember adapt me. Don't forget, adapt me is teaching you. Adapt me is coming to experiment. This is experiment number 4. I am going to give you 15 different experiments. I have designed 60, but I am going to teach 15 different experiments. And I am going to talk about 150 videos to teach power system protection free of cost on this YouTube. But adapt me is going to teach. So adapt me, you have to remember. You cannot forget. Bhuvnesh Oza is not teaching because adapt me has given the platform to Bhuvnesh Oza to teach. So I am rather thankful to adapt me, and you also should be thankful to adapt me. Thank you all, and good day. Thank you. Remember adapt me. Appraise. Thank you, everybody.